Hey everyone, and welcome. Today we're diving headfirst into the quantum realm.
Sounds exciting.
Yeah, it is. We're talking about controlling atoms with light.
With light.
Yep. You sent over this fascinating article from SciTech Daily
Oh yeah, that one.
about researchers at the University of Freiburg doing just that. It mentioned something called dressed states in helium atoms. So what exactly stood out to you in this expert speaker?
Well, what really caught my eye is how they're using incredibly intense lasers.
Intense lasers.
Yeah, to manipulate the energy levels within helium atoms.
Okay, so they're using lasers to mess with the atom's energy.
Yeah, essentially, they're creating these hybrid electron-photon states.
Hybrid electron-photon?
The dressed states,
Oh, yeah.
using light.
Press states, huh? I'll admit, that sounds a bit like we're giving atoms a fashion makeover.
Uh-huh. It does sound a bit like that.
Can we break that down a bit more? What's actually happening on the atomic level?
Okay, picture this. When you shine a light on something, you're bombarding it with photons.
Right. Light particles. Yeah. Now imagine cranking up the intensity of that light to an incredible level.
Like, how intense are we talking?
Trillions of watts per square centimeter. And they managed to do this in incredibly short bursts.
Wow, so it's like hitting those atoms with a supercharged blast of light?
Exactly. And these photons interact with the electrons in the helium atom.
The electrons that orbit the atom?
Yep, those guys. And it actually shifts their energy levels, creating these dressed states.
So it's like those electrons are getting a massive energy boost from the light.
Precisely.
Okay, I think I'm starting to get it. Now, the article mentioned they used a very particular laser for this, the FERMI free electron laser in Italy. Why this specific laser? Why not just use any high-powered laser?
Ah, good question. Most lasers, even very powerful ones, emit light in the visible spectrum.
The kind we can see, right?
Yeah, like the red laser pointer or green laser. But to interact with electrons in helium in this specific way, you need ultraviolet light.
Ultraviolet, like the
Yeah.
stuff that gives you sunburns?
That's the one. But we need it to be extremely intense. And that's where FERMI comes in. It can generate those ultra-intense UV pulses.
So it's like FERMI is speaking the right language to those helium atoms, huh?
Yeah, you could say that. Hitting just the right notes to shift those energy levels.
That makes sense. Now, there was also this term pulse shaping, and I have to admit, I'm a little lost on that one.
Pulse shaping. Oh, that's a fascinating technique. It's all about controlling the shape of the laser pulse itself.
Wait, so you can actually shape a pulse of light? How does that even work?
It's a bit like sculpting, almost. Imagine you have a basic lump of clay, and by applying pressure and shaking it, you can create something specific. Well, researchers use what's called a seed laser pulse to manipulate the main laser pulse.
A seed pulse?
It acts like a mold, shaping the main pulse, making it either disperse or contract in time.
Okay, I'm trying to picture this. So by shaping these laser pulses, researchers can fine-tune how the light interacts with those helium atoms.
Exactly, and get those dressed states dancing to their tune, so to speak.
That's pretty incredible. But I have to ask, why go through all this trouble? What's the big deal about controlling these quantum states?
Well, the potential payoff is huge. Think of it this way. By controlling these states, we're opening up a whole new realm of scientific exploration.
A whole new realm, huh?
Yeah. Like right now, we're limited in how we can use those powerful lasers like FERMI. But with this kind of control, we could conduct much more precise and efficient experiments.
So we're basically sharpening our tools to get a much clearer picture of what's happening at the atomic level.
Exactly. And that's just the tip of the iceberg.
There's more. Okay, I'm hooked. What else can we do with this?
Well, this research can also help us understand fundamental quantum systems that were previously hidden from view.
Hidden. You mean there are things we just couldn't see before?
Right. You see, visible light has its limitations. It can't interact with all quantum phenomena.
It's like we've been missing a huge chunk of the picture.
Yeah, exactly. But with these intense UV pulses, we can potentially unlock secrets that were previously inaccessible.
Wow, so we're not just seeing things more clearly, we're actually expanding what we can even see in the first place. But I have to ask, what about practical applications? How could this impact our everyday lives?
Oh, absolutely. Perhaps the most exciting potential application is in the realm of chemistry.
Chemistry. Okay, I'm intrigued.
Just imagine being able to control chemical reactions with atomic precision.
Hold on, you mean like manipulating individual atoms to build things?
That's the potential we're talking about. Think about it, we could precisely assemble atoms to create entirely new materials with properties we can only dream of today.
Wow, like custom design materials.
Yeah, exactly. Or imagine developing incredibly targeted drug therapies that work at the molecular level.
Wow, so we could deliver medicine directly to where it's needed in the body.
You got it. It's like we're on the cusp of a new technological revolution, all driven by our growing mastery of the quantum world.
Okay, this is definitely mind-blowing. I feel like we've only just scratched the surface here. What about you, expert speaker? What has you the most excited about all of this?
For me, it's just the sheer elegance of it all.
Yeah.
I mean, we're talking about harnessing something as intangible as light.
Well,
Yeah, to control something as fundamental as the building blocks of matter. It's just beautiful.
Yeah.
It's a perfect example of how science can unlock nature's deepest secrets and use them to create something truly extraordinary.
I love that perspective. It really highlights the power of human ingenuity, right?
Exactly.
Our never-ending quest to understand the universe. But before we get too carried away with all the possibilities,
Yeah.
let's take a closer look at exactly how this atomic manipulation works, the specific mechanisms. What are the challenges and limitations researchers are facing?
Oh, that's a great point. You see, while the potential is enormous, we are still in the early stages. There are hurdles to overcome, and we still have a lot to learn. For example, one of the key challenges is achieving that level of control needed to manipulate individual atoms with the desired precision.
So it's not as simple as just, pointing a laser and saying, move this atom over there.
If only it were that easy. It requires incredibly sophisticated technology and a deep understanding of the underlying physics. It's a delicate dance, and even the slightest variation can throw things off.
So there's not much room for error, huh?
Not when you're dealing with the quantum world.
I can imagine. Now, earlier you mentioned that this research could help us understand those hidden parts of quantum systems. What kind of systems are we talking about here? How does this research help us see them?
Well, think about it this way. We've been using visible light to study the world for centuries, right?
Yeah, that's how we see.
But visible light only interacts with matter in certain ways. It's kind of like trying to understand the ocean just by looking at the waves on the surface.
Okay, yeah, I see what you mean. There's a whole lot happening beneath the surface that we'd miss.
Exactly. And there's a whole universe of quantum phenomena that happen at scales and energy levels that visible light just can't interact with.
So there are things happening that we just couldn't see before.
Right. But ultraviolet light, especially at the intensities we get from that FERMI laser, that allows us to see things differently. It's like we've been given a new set of eyes.
So it's not just about controlling atoms, it's about understanding the quantum world better.
Exactly.
That's pretty cool. But let's go back to those dress states for a second. You called them a hybrid of electrons and photons. What does that actually mean? How can an electron and a photon become entangled like that?
It really is one of the most bizarre things about quantum mechanics, isn't it?
It definitely bends my mind a little.
So you have that intense UV pulse interacting with the helium atom, right?
Right. That super blast of light.
And it's not simply a matter of the electron absorbing the photon and jumping up to a higher energy level. It's more complex than that.
Okay, so what's actually going on?
The electron and the photon, they enter into this entangled state. They become intertwined almost.
Like a quantum dance.
That's a great way to put it. And this new entity, this hybrid state, that's what we call the dress state.
So it's a whole new thing. Not just an electron, not just a photon, but something else entirely.
Exactly. It has its own unique properties.
Okay, I'm trying to keep up here. So by creating and controlling these dressed states, we're essentially messing with matter at its most basic level.
Yeah, that's a good way to think about it. We're manipulating those fundamental building blocks.
That's wild, and I bet it's incredibly delicate work. What are some of the biggest challenges researchers are facing when trying to control these quantum systems?
Oh, there are tons of challenges, but one of the biggest is coherence.
Coherence.
Yeah, these dress states are incredibly fragile. Even the tiniest disturbance can cause them to collapse. Imagine you're trying to balance a spinning top.
On a wobbly table.
Exactly. Any little vibration, and it's all over. So researchers are working on developing techniques to isolate these systems, shield them from external noise.
So they can keep those quantum dancers spinning. That must be quite a technical feat, but okay, if they can crack that, what's the payoff? What kind of applications are you most excited about?
Oh, the possibilities are endless. But one area that I think is really promising is in materials science.
Materials science, like building stuff.
Yeah. Imagine being able to design materials from the bottom up, atom by atom. We could create materials with properties that we've never seen before.
Like what kind of properties? Stronger materials? Lighter materials?
All of the above. We could build things that are incredibly strong and also incredibly lightweight, things that can withstand crazy temperatures. The possibilities are really limitless.
So it's not just about understanding the quantum world, it's about actually engineering it to do what we want.
That's the whole idea.
That's amazing. But I have to ask, could this kind of power be misused? I mean, it's a bit scary to think about what could happen if it fell into the wrong hands.
Oh, that's a very valid concern. Like any powerful technology, it needs to be handled with care. And that's why we need to be having these conversations right now. We have to talk about the ethical implications, and we need to make sure that this technology is developed responsibly.
It's a powerful reminder that science and ethics need to go hand in hand.
Absolutely. We need to think about the consequences, both good and bad.
This deep dive has been incredibly eye-opening. We've gone from manipulating atoms with light to shaping laser pulses and exploring the strange world of dressed states. It's clear that we're just beginning to understand the potential of quantum technologies.
And the journey is just getting started.
What stands out to you the most from all of this, expert speaker?
For me, it's the audacity of it all. We're not content with just sitting back and watching the universe unfold. We want to understand it, and we want to shape it. It's a testament to human curiosity and our drive to push the boundaries of what's possible.
I love that. It's inspiring, really. But we also need to remember the responsibility that comes with this kind of power, right?
Absolutely. It's a reminder that every new discovery comes with a choice.
A choice about how we use it. Well, this conversation has been absolutely fascinating, and I know our listeners are probably eager to hear more about the potential applications of this research. So let's shift gears a bit and explore how this technology could impact different fields. From medicine to material science and beyond, what are some of the most exciting possibilities on the horizon?
Well, the possibilities are truly vast, and it's hard to say exactly where this research will lead. But one area where we're already seeing some really interesting progress is in the development of new materials.
New materials. Okay, color me intrigued.
Imagine designing materials, like atom by atom, tailoring their properties for specific things.
Wow, it's like having a molecular construction set. What kind of properties are we talking about here? Could we make things stronger, lighter, more durable? I mean, what's the potential?
All of that, and more. The properties of a material, they all come down to how the atoms are arranged,
Right.
And how they interact. So with this level of control, well, we could create materials that are super strong but incredibly light, or materials that can handle like extreme temperatures. The possibilities are pretty much endless.
That's incredible. And earlier you were talking about custom molecules for drug delivery. Could this revolutionize medicine? I mean, could we target specific cells? Or even, like, individual molecules in the body?
That's definitely one of the most exciting possibilities. Imagine being able to deliver a drug right to a tumor, without harming any healthy tissue around it. Or even repairing damaged genes at the molecular level.
Wow, that would be life-changing for so many people. But it also feels like a lot of responsibility comes with this kind of power, right? We need to be really careful about how we use this technology.
Oh, absolutely. As we go deeper into this realm of atomic and molecular manipulation, the ethical questions become more and more important. We need to be having these conversations now, about the potential risks, the benefits, and we have to establish clear guidelines for how we develop and use this technology.
It sounds like there are so many questions to consider. What are some of the biggest ethical challenges we're facing? And how do we even start to address them?
Well, one of the biggest ones is making sure everyone has access to these technologies.
Mm-hmm.
We need to make sure the benefits are shared widely and don't just make existing inequalities worse. And we also have to think about the potential for unintended consequences. When we start manipulating matter at such a fundamental level, it's hard to predict all the possible effects.
So it's not just about the science, it's about the impact on society as well.
Exactly.
It seems like we need everyone involved, scientists, ethicists, policymakers, and the public.
I couldn't agree more.
Yeah.
It's a shared responsibility to make sure this technology is used for good.
Well, this deep dive has been truly mind-blowing. We've explored this amazing world of atoms and photons, the power of lasers, and the incredible implications of being able to manipulate matter at its most basic level. What stands out to you the most from all this, expert speaker? What would you say is the key takeaway?
For me, what really stands out is the interconnectedness of everything. I mean, we've been talking about atoms and lasers, but what this research really shows is how everything is connected. from the tiniest particles to the largest structures in the universe. It's all interconnected and constantly interacting.
That's a beautiful way to put it. It reminds us that learning about the universe isn't just about gathering facts. It's about understanding our place in this grand, interconnected web of existence.
Absolutely.
This deep dive has been so thought-provoking, and I really hope it sparked our listeners' curiosity about quantum technologies and the important ethical questions that come with them. Thanks for joining us on this incredible journey into the quantum realm.
It's been my pleasure.
And remember, keep exploring, keep questioning, and keep those questions coming. We'll see you next time for another deep dive.